All right, so we have a couple of measures of variability. And variability, remember, means essentially how much a data set changes, how variable it is. Variable means change. And so the interquartile range, which we had talked about before, is a measure of variability between the 75th percentile and the 25th percentile, the middle 50% of the data. There's another measure of variability that will eventually kind of lead us into some other ideas later on in statistics, and that's called the MAD, M-A-D, the mean absolute deviation. So the MAD is a measure of variability, and it's a different measure of variability than the IQR. They both give us some information about how changeable a data set is. And so the MAD is determined by the average of the distances of each data point from the overall mean. Each data point or each data value from the overall mean of the data. Remember, mean means average. So this is kind of like the average of the averages. So average of the average distance is what we're trying to say here. So if we look at all the distances away from the mean, we're looking for the average of those distances. So we're going to go through an example here that hopefully will make a little bit of sense. But we're talking about distance. We're talking about how far away something is from something else. So if you think about like a number line, the negative 10 is the same distance away from 0 as positive 10. Negative 20 is the same distance away from 0 as positive 20. So the average distance away from 0 of negative 20 and positive 20 would be 20 because they're both 20 away from 0. So if we average those distances. So here we have the data values from our last sheet, and that was the heart rates of some high school students in beats per minute. So that was what we used as data on our last note sheet. So if we look at this, at all the heart rates, the first thing we're going to do is average them up. Okay, we're going to average them up. So we're going to add them up and divide by how many there are. I did a little bit of work ahead of time here, but so I kind of did the calculations. But 72 plus 75 plus 81 plus 76 plus 76 plus 77 plus 79 plus 78. If you add those up, you get a total or a sum. I'm just going to write it kind of small on the bottom here of 614. So the mean would just be adding them up and dividing by how many there are. So 614 divided by 8 is 76.75. So the average of all these numbers is 76.75. So in order to do the MAD, we're going to use a little table to organize our work here. And so all we have to do here first is just write that number all the way down, 76.75. So that is the average heart rate. And we're writing it down a bunch of times because we're going to find the distance between this average, 76.75, and each one of the data values. All right. So to do that, we're simply going to subtract these two lists right here and here. We're going to subtract the data value minus the mean. So we want to know the distance. So if you look at 72 and 76.75, like how far away are those from each other? If I subtract them, and if I go from left to right, I'm going to get a negative number. 72 minus 76.75 is going to be negative 4.75 because that first student was below the average. The second one, 75 minus 76.75, is negative 1.75. Again, that student was below the average, but not by as much. The third student, 81 minus 76.75, is positive 4.25. So that student, you'll notice, was above the average. We're going to do that for each one. So the next one is negative 0.75. So that's almost right at the average, just a little bit below the average for the student. Same thing for the next one, same value, negative 0.75. The next one was just a little bit above the average. 77 minus 76.75 is 0.25, so really close to the average there. The next student was a little bit more above the average. If we subtract those two, we get positive 2.25. And if we subtract the last two, we get positive 1.25. So these are all of the differences between the student's heart rate and the average heart rate. But whenever we talk about distance, remember, distance is always positive. So distance from the mean is what we're calculating here. And to change a number into a positive, we're going to take the absolute value. That's where that absolute number comes in, the mean absolute deviation. So we're going to do the absolute value. If I want to know how far I am away from downtown Hopkins, I can calculate my distance, and it doesn't matter if I'm on the north side of Hopkins or the south side of Hopkins. It's always going to be a positive distance. There's not a positive distance and a negative distance away from Hopkins. So whenever we're talking about distance, we're talking about positive. So how far away is that first student from the average? Just 4.75. We're changing all these numbers to a positive. All right, so the distance away, even though they were below the average, the distance from the average was 4.75. So all we do is we just take the absolute value of all of the previous numbers. If it was already a positive number, then it just stays positive because it's a distance. So we're going to take all those numbers and change them to positives. And again, if they're already positives, we keep them there. All right, and now we're going to take the average of this list. So the average distance away from the mean. We're going to sum these up. We're going to add them together. And if you do that, well, that was kind of fun. Let's undo that. I didn't want a straight line. All right, well, in any case, if I add those together, I sum them up, I get a sum of 16. And once again, since there are 8 data values, let's actually do that over here. The mean absolute deviation, that's what this is now, is we're taking the sum of all of the distances and we're averaging them together. So the total distance was 16 divided by 8 data values, because there were 8 students, and that is 2. So the mean absolute deviation is 2. The average distance from the mean heart rate, from the average heart rate, is 2 beats per minute. And if you think about, is this pretty consistent? Or is this kind of all over the place in terms of the heart rates? Well, if we look at the heart rates and we think of 2 beats per minute is the average deviation, the average difference, the average distance away, that's pretty low variability in heart rate. Low variability. Not much variability. In other words, it's pretty consistent. Those students had a pretty consistent heart rate. It's not like some students had like 50 and others like had 120 and they were all over the place. No, they were pretty consistent. So that mean absolute deviation, looking at that, is pretty small. All right, so let's answer some questions about that, or think about that. For another data set, all the values are either 3 beats per minute above the mean or 3 beats per minute below the mean. Is that enough information to find the MAD, find the mean absolute deviation for this data set? If so, find the MAD. If not, what other information is needed? Explain your reasoning. Well, at first it kind of seems like, well, isn't that enough? Like the mad seems to be 3. But if I think about this a little longer, I'm not so sure, because we don't know how many students had 3 beats per minute above the mean or how many students were 3 below the mean. In other words, if I were to go up here and say, okay, well, let's say I'm going to change colors here just because I'm doing this off on the side. But if I had a few that were like -3 and then a bunch more were +3, like all the rest of them were +3, then the average deviation wouldn't be 3, because if I average those all out, it's not going to average out to exactly 3. If they were all +3, or if the positives got balanced out by the negatives, it'd be 3. In fact, what does this average out to? Now I'm curious if I did that, because I might have a bunch of kids that are +3 and a couple kids that are below 3. So let's see, 3 times 6, that's 18. 18 minus 3 would be 12, right? So 12 divided by 8 students. Okay, so that average would be like 1.5, right? So that doesn't tell me enough information here. So no, we would need to know how many data values there are. And how many are 3 beats below the mean and 3 beats above the mean to get the mad? All right, we need to see those data values. So just knowing that some were 3 below and some were 3 above doesn't quite give me enough information, as I just explained here above. Okay. Next statement here, next question. Several pennies are placed along a meter stick, and the position in centimeters of each penny is recorded. The mean position is 50 centimeter mark and the mad is 10 centimeters. What information does this tell you about the position of the pennies along the meter stick? So we know the mad here. So we know the average distance from the mean, which was 50, from the 50 centimeter mark is 10 centimeters. All right, so if they average 10 centimeters away, that means the average distance is 10. The average distance away from 50 is 10. So on average, the pennies vary from 10 centimeters below the means, which would be what, 40. So the average, the pennies vary, on average, the pennies vary from 40, which is 40 centimeter mark, which is 10 centimeters below the mean, 50 minus 10, and the 60 centimeter mark, which is 10 centimeters above the mean. All right, so kind of on average, the pennies are going to be between the 40 centimeter mark and the 60 centimeter mark. All right, so I'd like you to take a look at the questions below then, and take a look at those and see if you can think about what the answers may be for those questions and write those in.